In my other video, we skipped this page where we actually derived the general equation for a parabola. So let's take a look at this one. We have a parabola. Its vertex is 0, 0. Its focus is at the point 0, P. So it could be anywhere, right? And the directrix is y equals negative P. So further down this way. So if we have the focus is at 0, P, and let's say we have any point on the graph, point P, which is going to be x comma y. Now we're saying that every point on a parabola is the same distance from the focus as it is from the directrix. So let's take a look at this point that we would be measuring to that's on the directrix. This point on the directrix has an x value that's the same as the point on the graph, but what's its y value? Its y value is negative P. So let's write an expression for the distance from point P to the focus. So again, point P was xy, and the focus is 0, P. So remember our distance formula. Distance is the square root of x minus x squared. So let's just take this point minus that point. So x minus 0 squared plus the difference of my y's squared. Oh, that was a negative P, wasn't it? Oh, I'm sorry, we were in the focus, right? Focus was 0, P. You're right. So it would be y minus P squared. Now let's look at the distance from the point P, which was xy, to that point on the directrix, and that was x negative P. So the distance is square root of difference in my x values, so x minus x squared, plus the difference in my y's. Well, if I take y minus a negative P, that's going to be y plus P. Now, since those distances are supposed to be the same, we can set these two expressions equal to each other. So here is the distance from any point on the graph to the focus, and here's the distance of any point on the graph to the directrix. Well, since they're both square roots, and we want to undo a square root, we would square both sides. Now when I square a square root, it undoes it. So I'm going to be left with what's underneath. And we can simplify this a little bit. That's x minus 0 squared, so that's going to be x squared. And then we have y minus p squared. On this side, x minus x. Well, that's just 0 squared. And then we have y plus p squared. So let's simplify everything so we can solve for y. X squared plus, now remember, this is really y minus p times y minus p. And over here, that's y plus p times y plus p. When you square something, you multiply it by itself. So y times y is y squared. Then I'd have a negative py and another negative py. That'd be negative 2py. And then lastly, it's a negative p times a negative p, which would be positive p squared. On this side, y times y is y squared. I have py and another py, so that would be 2 py's. and then p times p would be p squared. Now we want to solve for y, so let's see what we can do. Hey, we have y squareds on both sides. What if we subtract y squared from each side? Ooh, we have p squared on both sides. What if we subtract p squared from both sides of the equation? Now let's see what we have. We have x squared minus 2py equals 2py. Well, we're trying to solve for y, so let's get all the y's together. So let's add 2py to both sides of the equation. I'm left with x squared equals 4py. Y is almost by itself. But right now, it's being multiplied by 4p. So let's divide both sides by 4p. And let's rewrite it a second. Those would divide out. And now I have y. Let's rewrite it as a y equals x squared over 4p. Well, it's like a 1, right? So that's like 1 over 4p x squared. So that proves how that coefficient is related to the distance from our focus to our vertex, or from the vertex to the directrix.